In this lesson, I will talk about the integral of elementary and basic trigonometric forms. The integral of elementary and basic trigonometric forms. So this is the list of a few of them. And this comes as a result of our understanding of the integral as the antiderivative. So the integral of x to the k dx is equal to this. Because when you get the derivative of this function, okay, the result is x to the k. The integral of cosine of k times x dx, where k is a constant, is equal to 1 over k sine of k times x plus c. Because when you get the derivative of this with respect to x, it should give you cosine of k times x. So that is what is happening when we are getting the integral. We are looking for the antiderivative. Okay, so let us show that formally, okay? Let us show it. Okay, so for the first one, the integral of x to the k dx is equal to this because, okay, going to this, okay, we can just ignore c. C is a constant, and the derivative of a constant with respect to x is 0. So the derivative of this function with respect to x is equal to, okay, this one is a constant, k plus 1. So you will just ignore it, or you will just copy it, and then you will bring down k plus 1. And subtract 1 from the exponent. And this is the result. This is what you call the power rule when you studied differential calculus. The derivative of 1 over k times cosine times k times x is equal to this. Okay? And k divided by k is 1. So it is just equal to sine of k times x. So why is that? Again, use your derivative, okay? So 1 over k, you can just leave it as it is. So the derivative of this is sine, okay? The derivative of cosine is sine. And then you will apply your chain rule. Sine of k times x, and then chain rule times k, okay? And then k divided by k is 1, okay? So if you were to get now the integral of this function, that's going to be 1 over k times sine of k times x plus c. How about this? Why is the integral of the square of secant of k times x equal to 1 over k times tangent of k times x plus c? Well, let us get the derivative of this with respect to x, okay? So that's going to be 1 over k times the derivative of tangent is the square of secant. And then you will apply the chain rule times k. K divided by k is 1, and you are left with this. So what this is telling you is you cannot do away with knowing the derivatives of functions. And that means remembering the list. Okay, so in most books in calculus, in standard textbook, in both differential and integral calculus, at the back of the cover pages, you have there the list of derivatives and integrals. What is the integral of 1 over x dx? Okay, so this is going to be ln of x. And of course, the integral of 1 dx, you can also write this as the integral of dx. So when you see this, you're assuming that there is a 1 here, okay? There is a 1 here. And it is equal to x. And that is so, again, from our definition of the derivative. The derivative of ln of x is 1 over x. And the derivative of x is simply 1. Linear properties of the integral. If f and g are functions whose antiderivatives exists, then this is true, okay? So the integral of k times f of x dx, you can move k outside of the integral, okay? So k times the integral of f of x dx. you can look at the integral as an operator. It's something that acts on your function. It is something that acts on your function. If you are getting the integral of a sum of two functions, that is the same as getting the sum of the integral of those functions. So you can look at this as distributing the integration over the operation of addition and subtraction. Now, having said that, I must remind you that we have no similar rules when our function is a product of functions. So this is not true. This is not true. Okay? The integral of a product is not the same as the product of their integral. It's the same with quotient. The integral of a rational function or a quotient, a function that is a quotient, is not the same as the integral of f divided by the integral of g of x dx. So the linear properties of integration applies to sum or difference or to a constant times one function. Okay, so let us use those linear properties to get the derivative of these functions. So letter A. So this is an ordinary polynomial function. So what's going to happen is we can distribute the integration to each of the terms. Okay? And we can move out the constant coefficients. Okay? Okay, so we will apply your power rule. Okay, so this is what you call your power rule. In differential calculus, you subtract 1 from exponent and you bring it down and make it into a factor. So the opposite will happen for integration. So what's going to happen is you will add 1, okay, plus 1, and then you will divide by the exponent, 3 plus 1, which is 4, okay? So it becomes, okay, 4 divided by 4 is 1. So this is simply x to the 4. The same with this. X squared, the integral of x squared dx becomes x to the 3 divided by 3. 3 divided by 3 is 1. And the integral of 1 dx is x, and then you will add c. How about this? So again, this is the application of your linear forms. You can distribute the integration to the terms of your polynomial function. So here, okay, you can bring out 24 outside, bring it outside the integration. So the integral of x to the 7 is this one, x to the 8 over 8. Okay? X to the 8 over 8. 8 is a common factor, so this one will be simply 3. The integral of x to the 5 dx is x to the 6 all over 6, and then divide common factors. 3 is a common factor. Here, square root of 2 is a constant. So the integral of x dx is x squared divided by 2 plus c. What is the integral of 2 over x squared minus 3 over x cubed? Again, the linear properties. What you will do here is you will write this as x raised to negative 2 dx. Okay? And this one, you can write this as the integral of x negative raised to negative 3 dx. So that is our definition of negative exponents. And you will apply your power rule. So this becomes, okay, you will just copy 2. So this becomes negative 2 plus 1, which is negative 1 all over negative 1. So that's it. X to the negative 1 is 1 over x. Okay? And this one, the integral is going to be x to the negative 3 plus 1. So it becomes negative 2 all over negative 2. Okay? And so that's it. So negative, and then you have a negative here, it becomes positive. And of course, you write this in the denominator, 1 over 2x squared. And then, of course, plus c. So for letter A, okay, at the first glance, it looks kind of intimidating. But using what you know about division, you can actually write this as, so why is this so, okay? Why is this so? Because this integral can be written as, okay, the integral of 4z squared over z squared minus z all over z squared. dz, okay? So this is just among the properties of your fractions. And so we divide common factors. So this becomes 4 dz minus the integral of 1 over z dz. And so we apply our power rule. So the integral of 4 dz is 4 times z. And the integral of dz over z is ln of z. And then don't forget plus c. How about this one? Okay, so this one should be easy. So the integral of sine of theta d theta is negative cosine of theta minus, what is the antiderivative of cosine of theta? It is sine theta. And then plus c again. Letter C. Again, your linear forms. This is equal to the integral of t squared dt minus 2 times cosine of t dt. Apply power rule to t squared. T raised to 3 divided by 3. And the antiderivative of cosine of t is sine. And so the integral of cosine of t dt is sine of t and then plus c. Obtain the indicated integral. So what do we do with the first one? Well, this is the square of a binomial. You expand it. Okay, you expand it. X minus 3 times x minus 3 is equal to x squared minus 6x plus 9. Okay, and this is where you will apply now your integral. You will apply the linear forms property of your integration. So the integral of x squared becomes x cubed divided by 3. This one becomes negative 6x squared over 2 divide common factor. 2 is a common factor. That is why this becomes 3. And the integral of 9 dx is 9 times x plus c. How about this? The integral of z plus the square root of 2 times z squared. Okay? You might be tempted to expand this right away, which is not wrong, okay, but it will bring you into the thick of the forest, so to speak. Okay, but if you have a keen eye, you would see that z is a common factor. You can factor it out, and applying your rules of exponent, it becomes z squared plus this one. So this one is just a constant. 1 plus the square root of 2 squared is a constant. You can bring it outside the integral sign. And so you will just apply your integration here. Z squared. And what is that? What is the integral of z squared dz? Well, it is z cubed divided by 3 and then plus c.